Hi, I'm Lucas Mancuso, and this is our bottle rocket. For the design of the rocket, it needs to fit certain design characteristics and criteria regarding weight and aerodynamics. So more with the background physics for this rocket is going to be Victor Escobedo.
Due to inertia, the higher the mass of our rocket, the less impact the wind will have on the trajectory. However, our thrust is going to have to overcome whichever weight we decide on. So we can improve stability by adding fins to increase the aerodynamics of the rocket and make sure that the drag is slowing it down and keeping it stable, turning it where it needs to. We can improve the nose cone, make sure the wind is streamlined through it. And we can also go ahead and make sure that the center of pressure is going to be below the center of gravity.
My name is Daniel Adaway, and I will be talking to you all today about the wings in our Ratliff Relay water rocket project. For the material, we ended up picking balsa wood due to its low weight but high strength. This is because every gram counts towards lowering the weight of this rocket. In our wing design, we added a little tail fin there at the end to help with our stability, moving that low pressure area further out. That way it's not directly behind the bottle, making it a lot easier for us to be able to control where this rocket is going while it's flying through the air.
Hello, my name is Alex, and my part on the Fluid Flyers team was to do the initial design for the nose cone. Of course, with maximizing performance, overall performance, including weight savings, flight time, and aerodynamics. So besides that, I also did a lot of the manufacturing for the testing. We used 3D printing as our manufacturing software, and we also used it for rapid prototyping. So we definitely faced some challenges with both of these things, but we definitely have found a optimized medium for both, especially in terms of deciding on nose cone shape. So overall, really good.
My name is Logan Book, and I will be covering the challenges we faced. Starting with our nose cones. Our blunt nose cone had much more drag, but consistently more stable flights. Our pointed nose cone tended to go much higher, max altitude, but if unbalanced, it would veer or tumble. Another common point of failure was our adhesives. The superglues and epoxies caused the wings to break, whether on impact or in flight, not completely sticking to the bottle. Hot glue would cause warping in the plastic of the bottle. We had other inconsistencies in launches to include weather, pressure differences, the overpressure valve failing at an earlier pressure, like 35 to 40 rather than the 45. Those are the most common issues we were facing.
It's important to note, despite our challenges throughout the design process and testing, that we did achieve many successful launches. Unfortunately, however, you will not see our most successful launches, as the data from those could not be recovered accurately. Instead, you will see the best results that we could manage to have accurate data from, as well as many, many failures. Oh.